Hello and welcome to this video tutorial on modeling security risk using tables. The tutorial is targeted to security professionals as well as anyone is interested in knowing more about security risk modeling. This tutorial will give you the basics to model security risk using tables. We will first introduce you to the NIST 830 tabular risk modeling approach to identify, communicate and document security risks. We will also explain you how to evaluate security risks. Now, let's see how security risk can be represented using the tabular approach supported by the NIST 830 standard for security risk assessment. The NIST standard uses the following concept to denote security risk. A threat cert is an entity that initiates a threat event. A threat event is a situation that has the potential for causing undesirable consequences or impact. A vulnerability is a weakness or a flaw that could be exploited by a threat source. The impact is an harmful event that may occur given the potential for threats exploiting vulnerabilities. An asset is an operation, an individual, physical or non-physical entities that can be harmed due to a threat event and its impact. A security control is a safeguard or countermeasure to protect the confidentiality, integrity, availability of a system and its information. The overall likelihood is the likelihood or probability that a threat event results in adverse impact. The level of impact is the degree of impact in terms of harm to assets. Now let's give a look to a NIST risk model. The table in this slide provides an example of application of the NIST risk model. Each row in the table represents a threat event. If a threat event has an impact on one or more assets, there will be a separate row for each asset attacked by the threat. For example, in this table we have two threat events initiated by the threat source customer. In the first scenario represented by the first two rows, the customer exploits vulnerability, lack of compliance with terms of use to initiate the threat event customer share credential with next of kin. The threat event results in the impact unauthorized account login, which affects the asset integrity of account data and user authenticity. In the second scenario, represented by the last two rows, the customer exploits vulnerability, negligent customer, to initiate the threat event customer keeps credential on post-it notes, which leads to the threat event credential being revealed to third party. Also, this scenario results in the impact unauthorized account login, which affects the asset integrity of account data, user authenticity. The risk of the threat event is given by the likelihood that it occurs and the impact that it has on the asset integrity of account data and user authenticity. To reduce the risk, we need to mitigate the two attack scenarios. The first attack scenario, customer share credential with next of kin, is mitigated by security control regularly for customer terms of use. The second threat scenario is mitigated by the security control inform customers of security best practice. Now, let's see how we can evaluate the security risk of a threat event in terms of its likelihood and impact. The risk value of a threat event is computed based on a risk evaluation matrix. The matrix has on the rows the possible value that the likelihood can assume, while the columns instead represent the possible values that the impact can assume. The entry of the table represents risk values. Risk value represented in green denote risk that can be accepted. Entries denoted in orange represent risk that needs to be monitored. Red entries instead represent risks that needs to be mitigated, needs to be treated. So a possible security control for this risk needs to be identified and implemented. Let's now introduce the home banking scenario that you will analyze during the experiment. The online banking scenario focuses on the online banking services provided by Poste Italiane to their customers. Customer can access their bank account information through the Poste Italiane application or through the Poste Italiane mobile application. Customer can perform operations like checking their mobile balance, checking their credit cards, or topping up their mobile phone. The assets to protect in this scenario are the integrity of account data, which include personal information as well bank account balance information. User authenticity, which means that the person that is logged as a user is identical to the user. Confidentiality of customer data, which includes personal information, information about saving, loans, account balance. And availability of service. The online banking services shall be available to the customer 24/7. This concludes the tutorial on modeling security risk with tables. Thank you for your attention.